Hi guys, so we're going to start our unit this week and into next week of systems of equation. So a system of equations and really inequalities, and you could do quadratics, really a system as anything is a set of two or more equations that use the same variables. And are conjoined with a bracket. So we'll do word problems, and the word problems will relate to each other. Like if 60 adults and 20 kids went to a show and it cost $70, and then the same show, 30 adults and 10 kids went and it only cost us 15, we're going to be able to find the adults and the kids are still relating to the same show price. So here's the bracket of what I mean right there. So that's where if it's not in context, we have to know it's related. It kind of tells us that, hey, this x and this x mean the same thing. This y and this y mean the same thing. So we know our solution. So the solution to a system is where the point where your equations intersect. In Algebra 2, we're only going to deal with two variables. In Algebra 1, we only do two variables. In Algebra 2, you can do three variables. The three variables is not that much harder, it's just a little different solution. So we're going to start off with the easier one of graphing. So graphing is tedious if you don't have a graphing calculator. But so here, if we go and think about our equations, okay, so someone's already graphed them, and we know our point of intersection. So we're gonna, our intersection, so our solution would be, let's see, we're 1, 2, 3, 4. And we're 1, 2, 3, 4, 5, 6, 7, 8. So our solution is 4, 8. That's our answer. Okay, so over here we're gonna identify our solution. So the point where they intersect. And we know we're going to be like 1, 2, 3, 4, 5, 6, 7. So -7. And then 1, 2, 3. Okay. So that's our solution here. Sometimes they can express it in a table. And in a table, we're going to want to look to see where our outputs match up. So our outputs match up in this row. So I know my solution is going to be 2, -11. Over here, when we look here, we got to look for our outputs up. You see they both match up with our table. So we know -3, 12. That's our solution. So that's if they gave us a graph and we had to find the solution. Unfortunately, these problems don't really exist that often, so they get a little harder. All right, so here we're going to talk about solving by graphing. Solve each equation for y first. Graph all the equations, same coordinate grid, so you don't want to have two separate ones because it's very hard to graph. And then look for the point of intersection. We're going to do a little, so if the lines, little notes. So if the lines are parallel, okay, there's going to be no solution, because there'd be no point of intersections. If the lines are the same, we're going to say infinitely many solutions. I think I spelled infinitely wrong, but you get it. Or you can say real numbers. We don't want to say infinite solutions because that could mean the answer could be anywhere on the coordinate graph. We want it to tell the reader that it can only be on that line. So again, if they're parallel, there's no solution. If they're the same line after you graph it, they're infinitely many, or all your real numbers. Okay, so let's get this into solve for y first. So here, we know we have the brackets, we know they combine. So I'm going to add x. So 4y equals x plus 16. So y equals 1/4 x plus 4. So I'm going to go graph this guy on my number line. Not my number line. That does make sense. 4, 1, 2, 3, 4. And we'll go graph 1/4. Up 1 over 4. 1, 2, 3, 4. Down 1. 1, 2, 3, 4. It's important that when you're graphing with your systems that you're really specific with your points. So doing more than one point in each direction, you might even want to go 1, 2, 3, 4. You might want to just really make sure that 1, 2, you have your line 100% correct. Because we're going to look on the graph. So that's that guy. I'm going to do it in 2 different colors. So I'm going to graph this guy in my blue. So I'm going to go to -1. And then I'm going to graph 3, 1, 2, 3 over 2. 1, 2, 3 over 2. So I like to kind of count my graphs till I intersect, so I don't have to worry about did I draw my line straight enough. Remember, extend our lines. So we're going to look for the point of intersection, which is that guy right there. So I know my solution is going to be 1, 2, 3, 4, and then 1, 2, 3, 4, 5. And we can check this to make sure it works out by plugging in. So 4 times 5 minus 4, does that equal 16? 20 minus 4. So we know it works in the first one. And now let's do 5 equals 3 over 2 times 4 minus 1, 2, that's 6. So they both have to work in. You don't necessarily need to do the check, but the check helps to make sure that you graphed it right. All right, tomorrow during class we're going to practice graphing and start with substitution. I'll see you tomorrow.